Hello and welcome to the Firmware Guy channel. I'd like to thank a couple of inspiring channels, Flight Test and Juke Broking. They have some great videos. Go check them out. The goal of this channel is to provide clear and consistent examples of Uno code, but not only that, to provide examples that can execute on both, say, the Uno and Atmel part and the Arduino 101 and Intel part. So portability and how to strategize how to do that are some of the primary goals. Along the way, I'll be working on explaining things like I2C and SPI and USB. Eventually, I'd like to go through all the interrupts and give examples of both for both parts. I'll also be covering some of the low-cost debug tools as well as some of the environments available for development and debug. The goal is to have fun. I've been doing this kind of work for 25 years and I still enjoy doing this every day, and I hope to pass it on to somebody else and pass on my knowledge. So let's go out and have some fun. So for the first project, we're going to develop a Tricopter flight controller for both the Arduino Uno and 101. We use a standard radio and we'll integrate rotational sensors. In this case, the Uno has an external one and the 101 has an integrated one, but speed controllers, motors, and servos. And along the way, I'll pass along some of my knowledge on how to optimize control systems and operating on microcontrollers with a minimum amount of resources. So I believe this channel will appeal to a broad range of people. Anybody interested in embedded firmware, seeing Arduino examples for interrupts, and I'll do multiple examples of each one if I can, from the highest level library one, which may not be the fastest executing but is easiest to do, to a lower level one and occasionally assembly implementations to show the various ways it can be done. Also, anyone interested in how RC radios and servos interface with a microcontroller with a bit of control systems thrown in would probably find this interesting. Is my approach to things the only way to do it? Of course not. But I've learned throughout my long career that there are a few right ways to do it. There's more than one right way, but unfortunately there are tons of wrong ways to do things. And I'm going to try and highlight some of those pitfalls and at least give everybody a framework that they can know at least one right way to do something, at least in my opinion. And I think I've got relevant experience to share it. I've been in industry for 30 plus years, have 5 patents with 4 pending. So I think I have something to offer. What is my approach? My approach is that code clarity, at least with respect to code, and we'll talk about larger projects and how I approach things in later episodes, but let's stick with code clarity for now. Readability is the highest priority, even at the expense of minimum code size and possibly fastest execution speed. Nothing is more confusing than code that may have been so optimized that in 3 months it's unreadable and you can't remember what you did no matter how many comments you have. I don't believe in magic numbers. You'll see all the chip registers and bits are always defined. I will put chip spec references in the code. They'll be clear and well-explained examples. I believe clear and well-explained examples are the best teaching tool. And I think everybody should code to a standard. I'm not saying mine is the only one, and this usually starts a religious argument in any organization. But if you develop a coding standard and stick to it. And lots and lots of comments, and work to keep the comments current and relevant. Nothing is worse than code that has been changed and the comments are not changed equally to reflect the new one, the new functionality. So what's coming up next? And this is not necessarily a guarantee of order, but this is some of the topics I'll be covering. There'll be a quick explanation of how an RC radio works and pin change interrupts, implementing PWM using a timer on on both the Uno and the 101, rotational sensors with SPI and I2C interfaces, pros and cons. I'm going to go over some of the development tools like open source logic analyzers, their usage and my impressions. I'm going to include a video on the Visual Micro IDE for Visual Studio, what I think about that, and the advantages of fixed point versus floating point math for control systems and small microcontrollers in general. Thanks for watching my video. If you enjoyed my presentation and found it useful, please subscribe. All the examples that you will see and links to the current documentation can be found at www.firmwareguy.net. Thank you. Bye-bye.